Greetings from Team Keep Learning. In this video, we will see a first part of the combinatorics, that is permutations. So let's start. What does permutation means? Permutation means the number of different possible ways we can arrange a set of elements. The number of different possible ways in a particular set of elements we can arrange. So let's understand this with an example. Suppose there are three persons, Louis, Max, Kimi, and they are competitors to each other in a certain competition. Let's say it is driving. So there are three spots for them now, three awards or three positions for them: first, second, and third. First, second, and third. So now we will see one by one how these three competitors can obtain that spot. So in this case, our arrangement one would be: first will be Louis, suppose. Then we have two options. Second will be Max and third will be Kimi. Louis, Max and Kimi. First, second and third. Now suppose Louis is still the first, but Kimi is the second and Max is the third. Kimi is the second, Max is the third. Now in the arrangement 3, suppose Max comes first. Suppose Max comes first and Kimi is the second and Louis is the third. In arrangement 4, Max is still the first, but Louis came second and Kimi came third. And in arrangement 5, Kimi is the first, Max second, Louis third, and Kimi is still the first, and Louis second, and Max third. So in this way, there are total 6 different ways these drivers can split the award. There are 6 different ways these drivers can split the medal. So this is known as permutations. This is known as permutations because there are only 6 different ways these three can split the medal. Now we will see some deeper understanding of permutation. Suppose you have n many elements. Now I have given you example with three drivers. But now suppose you have n many elements, n number of numbers, and you have different spots to fill. So suppose at first place you have all the options. If you have n number of options, so for filling the first place you have all n number of options. And when you are choosing the second, this first option now gone. Whosoever you have taken, that option now gone. So you have n minus 1 option. Correct? You have n minus 1 option. You have chosen this also. So now you cannot choose n also and n minus 1 also. So now in the third place you have n minus 2 options. You have n minus 2 options. So order here is not fixed. In permutation, order here is not fixed. So at first place you had 3 options, then you have second 2 options, and then you have only one option. 3 minus 2 is 1. So order is not fixed. Now at the end when you have exhausted all data, of course you will left with only one choice. Here also you see only one option is remaining. 3 minus 2 is 1. So at the end of the day, end of the permutation, you will be left with only one choice. So this will always be 1 at the end. This will always be 1 at the end. So now I will read two important lines which you should understand. The further down the ranking we go, the more options we exhaust. The further down the ranking we go, that means one by one if we are start taking it, more number of options we are exhausting. The further down the ranking we go, the more options we exhaust. And more options we exhaust, the fewer options we have left. Of course, more options we are exhausting, so less options will be available with us, and at the end it is one only. It is one only. So how it will go now? If I want to convert it into mathematical notation, it is like this: P of n, that is permutation of n, is n into n minus 1 into n minus 2. At last it will be 1. And we denote it by this symbol, this exclamation symbol, and we call it factorial. So if I am writing 3 factorial like this, it means that 3 into 2 into 1, which will be equal to 6, and which is the case in case of our driver example also. Sometimes we write factorial like this also. This is also factorial 3. This is also factorial 3. Now, this factorial n means it is the product of all the natural numbers from 1 to n. So, if I am writing factorial n, it is 1, 2, 3 up to n. In our case, it was 3. So, factorial 3 means 1 into 2 into 3, 6. We have 6 different ways of splitting the award between 3 drivers. Now, we need to understand some important concept. First thing is that negative numbers don't have any factorial. You cannot write factorial of -1 or factorial of -3 like that. It is wrong. Negative numbers don't have factorial. And factorial of 0 is 1. Factorial of 0 will always be equal to 1. Why it is 1? Because 0 itself is an option. No? 0 itself is an option. 0 itself is an option. So in permutation we are basically seeing ways or different options. So it is 1 only. Factorial of 0 equal to 1. So far we have seen permutations. In my next video we will see variations. Why I am showing this in the last slide is because both are almost similar but not too similar. This basic thing you have to keep in mind. Both are similar but not too similar. That's why I am putting it on the next slide. By now we have seen permutations, and in the next video we will see variations. So if you have any doubt, any feedback, or if you need to give any suggestion, direct it to this mail, or you can comment it in the comment box below. Thank you.